All right. Well, welcome everyone to our annual virtual baseline monitoring refresher training. The goal of this 1 hour webinar is to provide you with some program updates from Emily and I on the statewide WAVE program. And really, we're just going to quickly run through the baseline stream monitoring methods and give you a chance to clarify, ask questions and clarify anything. And then we're going to wrap up at the end with a little more info about the new My Wisconsin ID login to SWIMS so that you have a chance to ask any questions you have about that. So I'll just ask that you um, stay muted and unless you'd like to speak and ask a question, just so we don't hear any background noise. And then please feel free as we're talking to type in the chat, which should be either at the bottom or top of your Zoom window. You can type or in the chat any comments or questions. We'll keep an eye on that as we're presenting and make sure you have a chance to ask questions throughout. So you can see Emily's comment. Questions are welcome here. Um, and yeah, I just want to start by thanking you all for your stream monitoring in past years and in this year ahead. These are some photos from the stream trainings and events that we had last year. And as you can tell, it's all a good time. And we're going to be getting started going out on the streams and training new volunteers this May. So we already got started. And it really takes a village to do all of this, and we really value having you part of the stream monitoring community in Wisconsin. So thank you so much. And just wanted to give you a quick look at 2024 volunteer stream monitoring. So all the orange dots on the map on the right are a stream monitoring site, whether it's baseline, nutrient sampling, deploying our continuous temperature sensors or thermistors. And we had over 500 stream sites that volunteers regularly monitored. We had 481 volunteers submitting data to SWIMS, plus all of their teammates, of course, who went out monitoring with them. And volunteers submitted over 4,000 fieldwork events to our statewide surface water database. So we have a lot of eyes on the ground monitoring and collecting data and being stewards of our streams and rivers. So if you want to see your data or others' data from last year or really any year going back to 2015, just a reminder that we do have a WAVE stream monitoring dashboard. Emily will drop a link in the chat, and you can also navigate to it by going to our main website, wateractionvolunteers.org. And this has Excel files you can download if you really want to analyze that data yourself, which can be particularly useful if, for some of our partners who want to collect data from a lot of sites in a watershed or in a county. We also have a little data interpretation on there. And once you've selected your stream site, you can also download an annual report on that data you collected and what it means for your stream. So if you have any trouble finding this, just reach out to us or talk to your WAVE coordinator and we'll make sure you get access to it. All right, so let's jump into monitoring this year. So just a reminder of the expectations we have of WAVE baseline volunteers. First is safety. Do not go out and monitor if there is a thunderstorm in progress and lightning. If the stream flow is really high, it's not worth it to go into that stream and get that data if it's not safe. And always go out with another person as well, just so there's another person out. Usually you're out of sight when you're in a stream, and we want to make sure there's someone else helping you out. So we have baseline volunteers. We ask you to monitor during the growing season. So once a month, May to October, about 30 days apart. You want to spread out your monitoring. Remember to submit your data promptly to SWIMS. We always have people who wait, lose data sheets, and then that data is lost forever. So it's best to just plan that when you're going to go out, make time to come home and enter that data into the SWIMS database. We'll also pull data from SWIMS for the WAV dashboard sometime in the middle of the summer. And so you'll be able to start seeing your data show up on the dashboard if you're submitting it every month. Um, we ask volunteers to take care of your own equipment. You know, maybe you have to use a Sharpie to relabel the depth markings on your DNet. Maybe you need to, right now check and make sure all your chemicals in your HOC DO dissolved oxygen kit are not expired, things like that. We really rely on you to make sure that you're collecting high quality data by taking care of your equipment. We also ask that you report any suspected aquatic invasive species you find. Emily will talk about that a bit later. And finally, stay in touch with your local WAVE coordinator if you have one, or with WAVE program staff if you don't have a local coordinator, because they are your local resource. And we support our partners, our WAVE coordinators, to support you. Um, When you're entering data into SWIMS, I want to ask that you watch for simple data entry errors like typing errors. So we do data quality checks on your baseline data you're entering into SWIMS every winter. And data entry errors are honestly the biggest problem we find. You can see a chart here showing that this volunteer accidentally mistyped dissolved oxygen, and it's showing 115 milligrams per liter, which we all know is impossible, right? And so that's a really easy fix. You can just go back into SWIMS, select your fieldwork event, and edit that number and save it. So, a few other reminders based on what we found. We had 9 volunteers who entered temperature in Fahrenheit instead of Celsius in SWIMS. You must enter your water temperatures in Celsius. We had 12 volunteers who had data entry errors for pH and dissolved oxygen, like I'm showing on the left. We had 26 volunteers who had stream flow errors in data entry in SWIMS. This one I really want to emphasize. If you do not enter your velocity correction factor, which is that 0.8 or 0.9 number for rough or smooth bottom streams, then SWIMS can't calculate the stream flow discharge for your stream. Same if you're missing the stream width, the stream length assessed. SWIMS won't be able to calculate the stream flow discharge. And lastly, we had some stream depths, which are just impossible for people to wade in, of over 6 feet. So those were some of the data entry errors and issues we found in SWIMS. And just keep an eye out on those, and you can always go back in and edit your data if you find an error. If you'd like help remembering what to monitor each month, we do have this one-page baseline monitoring calendar, which can help you keep track of your different parameters to monitor each month. Emily's going to drop this link in the chat as well. You can print this or just refer back to it. It's a nice resource, especially if you're newer to baseline monitoring and you need these reminders. All right, let's talk about setting up our stream site. We're going to get into the monitoring methods now. So when you arrive at your stream each year, you'll probably just returning to the same spot as always. But it's important that you select a particular spot along your stream that is accessible to you, and you come back and you collect data at that spot every year. Generally, we want to be sampling in a run of the stream rather than in riffles or pools. So that a run is an area of the stream that is flowing smoothly. Its pool would be kind of slow, and there might be an eddy that's kind of back flowing. So we want a run of the stream where the water is flowing nicely straight through, and a nice straight section for our stream flow as well. And then I want to ask that when you're filling out your baseline data sheet, please fill out fully the top of the data sheet. Uh, Fill out your official DNR station number, your official DNR station name, the date and time Those are really critical pieces so that we can tie your data to a specific place, date, and time. Um, Record who you went monitoring with, and if they're a regular volunteer, we encourage you to enter their name into SWIMS along with your name so that we can give your teammate who's going out with you regularly proper credit and recognition for monitoring. And then, of course, you're going to fill out the weather because weather has a big impact on what the conditions are in the stream that day you went out. So you're going to circle the weather for that day, write a few brief comments about temperature, precipitation over the past 2 days. The current stream condition, you're just going to, that's categorical. So you're just going to circle it, normal, flooding, dry, stagnant, etc. And if the stream is dry, we still want you to submit a fieldwork event and let us know that the stream is dry. And then write any observations that you're seeing that would impact the health of the stream. Like my stream, for example, in Pheasant Branch Creek has significant algae already on the stream bottom and floating in the body of the stream. Sometimes there is foam built up from, natural kind of organic materials and probably runoff from the urban area. If there's other concerns or even native wildlife and healthy aspects of the stream you want to comment on, feel free to do that as well. We were just at a stream training up in central Wisconsin last week, and there was pretty deep muck at the stream site. So I might comment on that and note how, hey, I'm seeing there's a lot of erosion along the stream bank at my stream site and deep muck in the stream bottom. So, I clearly there's a lot of sedimentation from an unhealthy kind of stream habitat along the stream corridor. Lance, thanks for your comment. Really wish those choices included low flow, which is quite often and never completely dry. It's a great suggestion. I can always make a note. And Emily, would you write that down somewhere to ask the biologist, hey, this seems like it would be valuable and really applicable to a lot of conditions that we experience. I totally agree. All right, so let's talk water temperature. Um, I'm just going to walk through the different baseline stream monitoring methods. The first few are really easy, and we'll spend a little more time on like dissolved oxygen, stream flow, and biotic index. The first data that we collect is our water and air temperature. So remember, anytime you enter your stream to collect data, you want to walk upstream from where you enter because you're going to be disturbing a lot of sediment and such. So enter your stream, walk upstream, hold the thermometer eye level and read the air temperature first because once you put that thermometer in the water, it's going to take a long time to adjust back to the air. And basically, you're just going to hold the thermometer into the kind of midway down into the stream column in until the temperature reading stabilizes. So you can pick it up and look at it at eye level, put it back in the water again, pick it up again and look at it eye level. And basically when the temperature stops changing, then you know that is the water temperature. And just remember, you're reporting your units in Celsius, not in Fahrenheit. So that one's pretty easy. And then and then transparency, sorry, I'm reading a comment. I leave the thermometer anchored for a while rather than trying to stand bent over. That's great. Yeah, if you have a way, I feel like most people don't have a way to leave their thermometer anchored into the stream. Maybe you can share, Juniper, how you anchor it in. I want to make sure people don't lose their thermometers, of course, but clearly you have a way to do it without losing your thermometer. That's a hot tip. It's a great suggestion. I would say usually it takes, I don't know, maybe a minute to let the stream record the water temperature. Um, so then for transparency, we use a 120 centimeter transparency tube with a Secchi disc, black and white Secchi disc at the bottom. So again, enter the stream with your tube, walk upstream so you're not disturbing that sediment and collecting sediment you just walked through in the tube. And then you're going to face upstream, so the water will be flowing into the tube, and put that tube about, again, halfway down the water column. You tilt the opening a little up and you'll see air bubbles coming out. And then put your hand while it's underwater over the top of the tube and lift it out of the water so that you have water all the way up to the top of your tube. Then you're going to come to the stream bank right away so that nothing, no algae or sediment in your water sample has a chance to settle. You want to stand with your back to the sun so you're blocking any light penetrating crossways through the tube. Remember to remove your sunglasses because this is a visual test. And what you're going to do is you're going to release water from the tube until you can just make out the Secchi disc at the bottom. So you can just see that black and white contrast of the bottom. If you've gotten too much sediment in your tube, for example, maybe you sampled after walking through the stream and you get some of that fresh sediment on the tube, you might have a layer of sediment in the bottom and you'll have to rinse it out and start over with a clean sample. That's just one of the situations that can happen. But then you're going to record the water level. So in the picture on the right here, it looks like we have a clarity of 61.4 centimeters. Usually you want to be concerned if it's at 55 centimeters or lower for an extended period of time. You'll certainly have poor transparency after a storm. But generally for long-term transparency, you want it to be above that 55 centimeter mark, or even clearer is better for aquatic life, typically. Um, and then remember that we take two samples and we get an average because there is variation. So if I take those two samples, add them together, and then divide by two for having two samples, that's how we calculate an average. So at this day on this stream, my average was 61.7 centimeters. So that's transparency. Let's talk about dissolved oxygen using the hot kit. All right, so as a reminder, again, make sure please check the expiration dates on all of your chemicals now, and make sure you have enough reagents and liquid chemicals to last you through October. It's easier for us and for your wave coordinator probably to supply you at the beginning of the season so that you're all set for the year. We usually give you a few extra reagents and liquids so that you can do multiple tests if you get a reading that you're not sure about. Um, to know if your starch solution is going bad or not, look and see if it's cloudy. Starch goes bad really easily. In fact, all these chemicals, you want to keep them out of hot temperatures. So don't leave your hot kit sitting in a hot car. And then you also don't want your chemicals to freeze because that can ruin them as well. So just keeping them in nice, stable temperatures is ideal. So that is step one. So when you go out to monitor, remember to select the method of collecting dissolved oxygen on your data sheet and enter that in SWIM. So we are using a hot kit today. Enter the stream and again, walk upstream so you get a nice clean sample and don't fill your bottle with sediment from walking through the stream. This is also a place where it's valuable to make sure you're collecting your sample in a run of the stream, not in a riffle, so not in the babbling brook part of the stream, and not in a pool where the water is kind of slow and there's an eddy and more stagnant. So we want a nice run of the stream for measuring dissolved oxygen. You're going to hold your glass bottle, as I'm showing here, underwater, about halfway down in the water column, and you can kind of twist it around to mix the water and get a sample. Then while the bottle's still underwater, hold it upright and put the cap on underwater, and that will ensure you don't get any air bubbles. Especially if you kind of hold the bottle upright underwater for a few seconds and let that air from the atmosphere escape. And then hold it up and check the rim just below the cap for any air bubbles. That's where they'll be hanging out. And if you're all good, you can bring the sample to shore. It's really valuable. It'll help to leave that little extra bit of water in the top of the cap, surrounding kind of the glass cap. It just helps to have a little extra water to work with. Um, because this test is all about measuring oxygen dissolved in the stream, you really want to make sure that you're not getting any air bubbles in the sample at this point. Because the first part of testing for dissolved oxygen is using the chemical reagents to fix the oxygen in the sample so that we can then test how much oxygen is in that sample of water and make sure we're not testing how much oxygen is in the atmosphere, right? We only want to know how much oxygen is in the stream available for fish and other aquatic life to breathe. All right, so remember to put on your goggles before handling these chemicals because there are some acids in there that would irritate or potentially damage your eyes. Um, and you want to start by adding one packet of DO reagent 1 and then one packet of DO reagent 2 to your sample, which I'm showing here. Then you're going to put the cap on your sample. You could kind of scrape the chemicals away off the top. Make sure before you shake that there are no air bubbles along that rim, kind of below the cap. If there are air bubbles, one strategy is to lift the glass top maybe an inch high and drop it in. Sometimes that can push out any air bubbles. Hold the cap and chemicals a chance with the oxygen in the sample. Um, so until the flock, the orange substance, has settled and separated. Once it has settled, you can pick it up and shake it a minute, and let it rest a second time as well. So that's what we're doing here. We let it rest twice. And Juniper is asking, sometimes it doesn't seem as though all the chemicals have dissolved, and does that matter? And no, I don't think that matters. I've seen that a lot as well. And you'll often have like little white kind of chemical residue at the bottom of the bottle. Um, I've seen this and then tested with a meter too, and it really doesn't seem to have an impact. So I wouldn't worry about that. If you feel like your chemicals are at risk of getting old or you don't trust them, you could always get a fresh batch of chemicals from your coordinator and try again and see if it makes a difference. Um, so the last step is to add the third reagent, DO reagent 3. And I know this one's hard to open, so sorry about that. So drop in that reagent 3, get that cap on without getting air bubbles in, and then you're going to shake that vigorously until it turns that nice kind of apple cider color. There's some kind of iodine related chemical in there. I'm not a chemist, so I'm not going to complain to completely understand it. But this is on the right what you're going to end up with. And once you've gotten to that point, with a nice clean apple cider colored sample, then you know the oxygen has been fixed in your sample, and you can put it down and walk away, and then we can test how much oxygen is in the sample. All right, let me pause for just a moment. Sorry, my cat was desperately trying to get in the room and I could not think with her bugging me. All right, so, and here she is, right behind me in a blur, so we don't get too distracted. So now our sample is stable. Our next step is to fill our cylindrical measuring tubes twice. So you're going to fill it completely to the top, and then you're going to pour it into your, whoops, square mixing bottle. So fill that cylindrical tube once, pour it in the square mixing bottle, fill it again, pour it in the square mixing bottle. We want two full tubes, and this amount of liquid is what we're going to titrate into to measure how much oxygen is in our sample. And this allows us to be accurate to the nearest 0.5 milligrams per liter. And then we are ready to what we call titrate. So this is where we're going to release drops of our sodium thiosulfate solution into our square mixing bottle sample and count every drop to discover how much oxygen is in our stream. So a few tips. Please remember to keep that dropper upright as I'm showing in the photo here. Don't hold it to the side because you might not get the same amount of sodium thiosulfate drop liquid into the square mixing bottle. And then when you're counting every drop, just remember to swirl and mix between each drop because you really need to give those chemicals a chance to interact with the oxygen or the other chemicals in your sample. And then when it has turned light yellow, and honestly, you can do this a little earlier if you want even, just add like 3 drops of starch solution to dye your sample blue. That will just kind of help you see the transition to clear in the sample. And the goal is to stop as soon as your sample turns clear. We don't want to add too many drops because then we're over counting how much oxygen is in our stream. So just 3 drops should do it. And you don't have to use starch, it's totally optional, but it can help see your sample turn from like that pale yellow. Instead of pale yellow to clear, you can see it turn from like that nice blue to clear. So you can kind of see on the right in the picture, I've dyed my sample blue with starch solution. But we don't count those drops in our titration. That's just a pause. We only count sodium thiosulfate drops. And so you basically keep adding your sodium thiosulfate and mixing really well until on the right you can see our sample has turned a nice clear. If you're seeing like blue floaties in your clear solution, that probably means your starch solution has gone bad and you need to replace it. It might affect your DO result. I'm not entirely sure. You could always get fresh starch and test again. I think you can generally trust your result even if you have those blue floaties. Yes, and holding your bottle against white paper, really helpful to see the difference between a pale blue or pale yellow and that nice clear point, because sometimes you just need to add that one more drop to get it nice and clear. And then your DO milligrams per liter is the number of drops divided by 2 tubes, because remember, use 2 tubes to sample. So let's say we added 20 drops of sodium thiosulfate, divide that by 2 tubes, then our value is 10 milligrams per liter of dissolved oxygen. And then the last step here is calculating the percent saturation. It's just another way of understanding how much dissolved oxygen is the stream given the water temperature you have and given the atmospheric pressure in Wisconsin, wherever you are in Wisconsin. So what you do here is you draw a straight line between whatever water temperature you measured that day and your dissolved oxygen in milligrams per liter value. And where it crosses that center line is your percent saturation. So here it looks like the value for if you have 10 milligrams per liter and about 4.5 degrees Celsius water temperature, then your percent saturation is going to be 74% or so. All right. So that's what that means. Feel free to ask any questions in the chat. I do need to keep going though, because we got lots of content, so Emily can keep answering questions as well. Okay, stream flow. This is the one that gets most people, that's tricky for most people. So first, I want to say that there are a few different types of streams. We have our perennial flowing streams. They always have water unless it's a really unique drought year that has affected all of our streams recently. But apart from perennial streams, there are also intermittent streams. These are usually wet. So they are often like wet most of the year and might dry up for a bit in like August or September. And we do want to monitor these streams that are usually wet. And then we have ephemeral streams. These are usually dry. So if you're like in a forest on the side, hiking through a woodland, and there's a really steep, like rocky channel that only has water after a storm, that's considered like an ephemeral stream, and we don't monitor ephemeral streams. So, stream flow discharge, there are really two parts to measuring stream flow. And this is how I think about it. The first part is measuring the area of the stream. You cut it like a cake. You measure the width at that point. And then you also take a bunch of depth measurements to get a average depth number. So we have two values, a width and a depth. And we multiply those together, and that gives us an area of our stream. And then the second part is measuring velocity, and we do that using the float method. So we float a tennis ball to see how much time in seconds it takes to float 20 feet. And we do that at the same space where we measured our area. So we multiply those values together, the width, the depth, and feet per second, distance by time, and that gives us our discharge value. I want to emphasize here, all your measuring tapes should be in decimal feet, not in inches. We want to make sure that we are not entering data in inches. Like we're not, so 1.5 feet, or sorry, there's an example here, 0.7 feet is 8 3/8 inches. We don't want the inches, we just want that 0.7 feet. Basically, you break feet up into 10 equal parts instead of 12 equal parts, which is what inches would be. All right. So start, we're measuring the stream width. So pull that measuring tight across the stream, pull it taut. You can use clips like I've shown here if you're doing this with one or two people and you just don't have an extra hand. And you can record the width then that way. So basically you look at the tape straight down and you see, okay, what is the number on the tape where the water starts? And then you look at that you do that again on the other side of the stream. And then you can subtract kind of the number on the right from the number on the left, and that is the width over the water. So that you can do that if like the measuring tape doesn't start at 0 where the water starts. Not sure if that made sense, but hopefully it does. It's hard to describe this and not show it. So then we have our width. We're going to write that down. Now we need to get an average depth. And because we're calculating an average depth, it's very important to measure at equal intervals across the stream. So you start where the water starts on the bank, the wetted edge, and you go 1 foot in from that, and that is your first measurement. You already have 0 on your data sheet, so you can use that to represent both banks. So your first written number at point number 2 on your data sheet is going to be 1 foot in from the bank. So basically take that depth measurement every foot, and remember, to write the number on the DNet and not the number on the measuring tape for your depth. I've done that a few times. Once you have reached the other side of the stream, if your last value is 0.2 feet depth, that is the last value you can write in your data sheet. You don't need to write a 0 for your last value because your first 0 on your data sheet at 0.1 is representing both banks. All right. So what if your stream is more than 20 feet wide? You only have 20 kind of blank spaces on your data sheet to write in depths. So all you have to do is take your stream width, let's say it's 23.5 feet wide. You divide that by your 20 points that you can measure, and then that's going to give you some weird number like 1.175 feet for your equal intervals, which is impossible to remember, so just round up. So you're going to take a depth measurement every 1.5 feet. Much easier to remember, and that still gives you a lot of data points to get a good, accurate average depth. And let's say you have a really narrow stream like here, then you can basically measure like every half foot across the stream. That gives you enough data points to get a good average depth. Equal intervals is what's most important. Okay, and then the second part of this is velocity. So you want to mark a straight 20-foot section of stream in a run of the stream. Again, make sure it's not like a pool where the water is slow and eddying back on it in on itself. You generally want to avoid riffles as well with lots of rocks and obstructions. So just a nice regular straight run of a stream. Measure 20-foot section and then fill your tennis ball halfway with water so that it kind of sits a little lower into the surface of the stream and doesn't get pushed by wind or anything. And then just use a stopwatch and measure 4 times how long it takes that tennis ball to go from one flag to your second flag, that 20 feet. We're going to take a velocity average. All right. If the tennis ball gets hung up on something like a branch or vegetation, you cancel that and you start over. And generally, you want to take measurements at different parts of the stream width because the water may be flowing a little slower on one side compared to the other, and we're getting an average velocity here. And then the last piece is the velocity correction factor. Don't forget this. Your swims will not be able to calculate stream flow without this number. So basically you just indicate if it's a rough bottom stream, rocky bottom, maybe a lot of aquatic vegetation, stuff like that. Or if it's a smooth bottom stream, like a nice sandy stream bottom or really flat like granite. So mark one of those options. And then I just wanted to share that, our float method is really accurate in a consistent way. It over measures stream flow by 24%. So SWIMS automatically corrects for that. But if you're filling out your data, your stream flow worksheet, there's this handy tool can help you do the math yourself if you're interested. Um, uh, this worksheet that I have, Emily dropped a link. It does have that correction in it. So you can do that at the end and just make sure that if you're comparing your float method to a nearby USGS stream gauge, then you will need to do that 24% correction. Basically, all SWIMS does is multiply your numbers by 0.76. So it drops your value down by 24%. If you are confused by the math, I find it helps to do the worksheet here at least once. Kind of helps you see how all the measurements you're taking work together to measure how much flow is in that stream. James asked, because our stream feeds a lake with a variable dam, yep, flow can vary. We sometimes vary the length of our segment from 10 to 50 feet. Yeah, I mean, it really doesn't matter if you basically write your length assessed for floating the tennis ball from 10, 20, 30, 40, 50 feet, whatever it is. The length assessed is important in the calculation. We say 20 feet because it gives the tennis ball a chance to match the flow of the stream. So most volunteers should use 20 feet, but if you need more distance, then that's fine. Okay. 20 minutes for Emily to run through her stuff. I did okay. I'm a little behind, but generally okay.
Yeah, you nailed it. All right. So now we're going to get into biotic index. We know that's everyone's favorite part of monitoring. We're looking for bugs, looking for macroinvertebrates. So As a reminder with the macroinvertebrate monitoring, you don't need to do it every time you monitor, just twice a year. So once in the spring and once in the fall, May and October. But if you love doing this and you want to do it each time you're out, you're more than welcome to. The goal with this overall is to survey a wide variety of habitats so for those bugs. So make sure you spread out across your sample site. We usually recommend searching an area of about 300 feet in length across the stream section. And that's because with sampling those diverse habitats, that's because the different bugs prefer different places to live in the streams. So the areas of highest diversity for those macroinvertebrates are riffles, and then that's followed by undercut banks, and then snag areas and tree roots, and then lastly, leaf packs. So you're going to be choosing three locations to sample from, choosing the most diverse areas you can find. So if your stream has a rocky bottom with riffles, a riffle is the most diverse area to find those macroinvertebrates. And if you have riffles, we would like for you to sample at two separate riffle areas and then at one other habitat. And if your stream has a soft bottom or if it doesn't have riffles, then you can collect samples at undercut banks, the submerged logs, snags, or the leaf packs. So to sample a riffle, you can see there's pictures of each of the different areas that you can sample. Sampling a riffle, when you gather one sample, it actually has two steps because you want to sample below and above the riffle. So we're going to start at the downstream side of the riffle. You just put your net against the bottom of the stream and start kicking in front of it. So we're trying to dislodge the bugs. So you can really kick it like you mean it because they're hiding under there. And after you've kicked it about 20 times, have your partner hold the net and you can pick up some rocks and rub them together in front of your net and then dump that net into your tray, which make sure it has a little bit of water in it because remember, our bug friends need water to survive. And then repeat that process on the upstream side of the riffle. Dump the net into your tray. And then remember, you can do that at a couple different riffle sites. To sample at the undercut banks, which you can see in the top right image there, you can scoop the bank from the bottom to the top about 20 times and then dump your net. And then snag areas and roots. So snag is like a fallen tree. You can see that in the bottom right. You can just run your net along about a 3 by 3 foot area and then scoop along the surface. For leaf packs, you'll then want to hold the net downstream and scoop some leaf material into the net and bring that slowly back into the tray to sift for bugs. Just make sure you don't grab a big handful of mud while you're doing that. It's going to make your job a lot harder if you have to look through all that mud. Um, so again, just choose three of the diverse habitat types to sample from. Should we pick out and look at any rocks on the bottom to find caddisflies? Yes, you can do that, Lance, especially if it's within a riffle area, then you'll get that when you're kicking up on the rocks too. Okay, I think it's the next slide here, Katie. So once all of your samples are collected and you can dump them into the big tray, again, has a little water in it, then I would let that tray sit for a couple minutes because it's if you did get a bunch of muck and yuck in your sample, it's going to give it time to settle out a little bit. And it also gives the bugs time to start kind of emerging from hiding. So you can use your ice cube tray to sort those macroinvertebrates by similarities. Again, make sure the ice cube trays have a little bit of water in it or you'll kill your bug friends. And then you can use the key to the life in the river posters that are included with your kits to identify the bugs you found. And on your data sheet, you just circle each of the bugs you found or check depending on which version of the data sheet you have. And you tally the number of bugs circled in each sensitivity group. And that's what you enter into SWIMS when you're doing your data entry. So it's just a presence absence. So if you found 10 caddisflies or if you found one caddisfly, you're just checking caddisfly was present. Next slide, please. We know that, identifying the macroinvertebrates isn't always the easiest task, even though it's really, really fun. And so there are some nice non-wave identification resources that you might be interested in for identification. So there's a website called macroinvertebrates.org. It has really nice pictures. Honestly, it's just really fun to look at, even if you don't feel like you need the assistance. The pictures are really, really beautiful and fun to look at. And then there are smartphone apps that you also might enjoy. One of them is called Pocket Macros that has really nice pictures. And then there's also an app called iNaturalist. So that's it's for a wide array of nature reporting topics that includes macroinvertebrates. And you can upload photos for identification assistance from the community. And of course, you're always welcome to take photos and email them to your local coordinator or to us at WAVE, and we can help you out. Next slide, please. And then, as a part of baseline monitoring, especially during macroinvertebrate monitoring, we're asking that our volunteers keep an eye out for four species of aquatic invasive species, also called AIS, while you're out doing your monitoring. And there's not a specific protocol to look for invasive species. We're just asking you to keep an eye out. Again, you're most likely to see them when you're doing the biotic index and kind of rooting around in the muck, but it's good just to keep an eye out each time you're out there too. And the four species that we're asking folks to look out for are New Zealand mud snails, faucet snails, rusty crayfish, and freshwater golden clams. So those four species were chosen by the DNR, Department of Natural Resources, as especially concerning species. Some of them, most of them are not very widespread, or they're trying to keep track of the spread, as in the case with rusty crayfish. So anything that you guys are finding that you do think is suspect, I'm going to recommend that you take a sample of it, especially the snails and the clams. They're so, so tiny, and it's really hard to get a good picture to identify and photograph them. And the snails, actually, if you send in specimens of them, they're ultimately sent to a lab to identify because they have to be looked at under a microscope to confirm. So they can be tough to identify. That's why we asked you to grab a sample if you have any doubts. And then you can report your findings to a local DNR AIS coordinator. So Katie's going to put a link in the chat to find your local contact for that. Or you can always contact us at WAVE and we can put you in touch with the correct DNR AIS contact, because then they're going to take it from there and go out and do their own sampling after they've confirmed or denied the identity of, of the specimen that you send in. And
Emily,
so,
let me pause share for a sec so I need to open this link without sharing my all my stuff. Hold on.
okay.
Okay. You see it?
Are you sharing a screen?
Yes.
No, I still see the invasive species monitoring slide.
Yeah, that's what you should see.
Yes. Okay.
All right, go for it.
All right. Did you have that link in the chat too for the AIS contacts?
Yes. I'm pulling that now. All right.
All right, I think I have one more slide here on invasive species if you go
There
forward.
we go. All right.
Okay. So if you do think you found an invasive species, you can obviously always contact DNR right away, contact your local coordinator, but you can also do a little pre-research to help us out a little bit and see if you might need to even report it in the first place. So there is a DNR website. Katie's going to put that one in the chat too, that lists all the known AIS by water body in Wisconsin. So you can use that website and look up your stream and see what are the known species that are already in there. And if the species you found is not listed there, you should definitely report it to the DNR. Bring a specimen to your local WAVE coordinator or contact that DNR contact. If the species is already found there, it's already known. A lot of our streams have rusty crayfish. You don't need to take a sample of that. You can just report it as seeing it when you're entering your data into swims. Next slide. And if you have the AIS monitoring bug, you are welcome to Learn a little bit more species identification through Project Riverine Early Detectors or Project Red. There's information on our webpage about that, wateractionvolunteers.org/Project Red. And we just want to do some swims reminders to wrap things up here. Just as a quick note before we get too into the big changes of swims, if you need a refresher on entering data into swims, make sure you check out the data portion of our webpage and the submit data. Katie made a really, really nice video. It's short and sweet and concise that walks you through step by step how to enter all the data. So there is a video for you there as a refresher. And now for some changes coming to swims. The biggest and only change right now that's coming in early May is that the method of logging into swims is changing. So right now you currently use what's called a WAMS ID to access swims. So you might remember the process of setting up the WAMS ID and then you had to email us your username and then we go in on the back end and link your WAMS and swims accounts. So it's a two-step process to be able to log into swims there. But in early May, WAMS is going away for logging into swims, and you'll now need to use what's called My Wisconsin ID to log into swims. Only the method of logging in is changing. Nothing else is changing. So your data is still in swims. That's not going away. Once you're logged into swims, the way you enter data is still the same. So that video will still be relevant. So everything in swims looks, feels, and functions the exact same as before. The only thing that's changing is how you log in, and you need to create the new login username and password to do that. We can go to the next slide, Katie. And again, that change to logging is coming in early May. And until then, your regular method of logging in is still going to work. We will absolutely be letting you know through email once that change occurs and when you need to start using that new method of My Wisconsin ID. So after the change occurs, you will no longer be able to use your WAMS ID to log in. You need to use your My Wisconsin ID. So a lot's happening on the back end to make the change possible, and we're just asking for your help to help us prepare for this change. And so we're asking that you start by creating your My Wisconsin ID in advance. It will not work to log into swims yet. Keep using your current method of logging in until we let you know. This is just so you're ready when the change occurs and we can try to, if you have any issues, we can try to troubleshoot them ahead of time. We're all gearing up so that when the change occurs, we're just gonna smooth sail right into continuing to enter our data. Um, so create that My Wisconsin ID in advance, and then we're also asking for you to update your WAMS profile with your most current information, including an email address that you use and check regularly. So I know for me personally, when I first made a WAMS profile, it was for my last job. So I had to go in and update my profile to be my current email address and mailing address. Um, and you can let us know if errors occur during this process. Some of the errors we can troubleshoot in advance. Some, unfortunately, we cannot, and we just document them and we'll take care of it once the changeover occurs. If there's any issues ahead of time that we can't address, that doesn't mean that you'll never be able to enter data in. It's just going to take a little bit longer. So no matter what, you will absolutely be able to log into swims once the changeover occurs. We're going to help you through the process and it's going to be okay. Um, let's go to the next slide, Katie. So, yep, that's again here. No matter what, we're going to be able to help you log into swims. It's just going to take a little bit of patience. It's a learning process for all of us. We appreciate your patience. We know that swims isn't everyone's favorite, but it's really important. And just know that with this process, that the reason for all of this is for increased security. And so it's going to be more secure for you. It's going to be more secure for the DNR. And then also there's going to be a help option available if you have problems with your account. Right now, if you have problems with your WAMS ID, I don't know if anyone's ever tried to get a hold of the WAMs folks. It's not easy, but getting a hold of the My Wisconsin ID people will be much easier. I've already called them and talked to them on the phone a little bit. Next slide, please. So we have sent a few emails already that detail exactly how to create the My Wisconsin ID and how to update your WAMS profile. We include the step-by-step instructions and the links to each of them. So if you did not get those emails, please let us know and we can forward them to you. I can write down names and emails now, or you can email the WAV email address and let us know, and we'll forward those to you. So again, continue logging into Swims as usual. We will let you know when that switch occurs. We'll be sending emails and letting all the coordinators know to send emails to their groups. So just for now, keep doing business as usual. Front load the work with creating your My Wisconsin ID and update your WAMS profile. Next slide. Okay. So I have had some questions of people when they do create the My Wisconsin ID. They're wondering if they did it right after they created the new My Wisconsin ID. So if you get a boring screen that says you need to add apps, that's a good sign. That means that your account worked. Nothing's added to it yet because the changeover hasn't occurred yet. So something that's asking you to add apps with a little rocket ship and it looks like a bunch of nothing, that's a good sign. All right, and next slide there. So, just remember, we're always here to help you with SWIMS issues. You can email us with questions. It's a busy time of year for us, but it's a busy time of year for everyone. So we're gonna work together. Send us email if you have any questions with connecting to a new stream monitoring site if you've moved, any SWIMS issues and areas that come up, or if you need help fixing a data entry error, send us an email, wave@extension.wisc.edu. And our contact information is there again. I saw Juniper asked you send us an FYI if you notice we had a data entry error. Katie took care of that. I believe she did email people that had real glaring errors. Is that right, Katie?
Yes, so I can over the winter, like basically run a quick analysis and find values that are impossible. And I did email volunteers who had those types of data entry errors. I'm hoping to be able to do this every year. This was the first year I had time to do that. So I have asked our WAVE coordinators to keep an eye on data as it's being submitted by looking at the WAVE dashboard and see if they see errors, data entry errors. So really though, we rely on you if you have a data entry error and it is a possible value, like for example, if you accidentally write in 1 milligram per liter for DO instead of 10 milligrams per liter. Um, I might still flag that as an concerning value, but it is a possible value also. So I guess maybe that's a bad example since that's a really concerning value for DO. But yeah, I the answer is sometimes we send you a notice if we're able to. I think my neighbor wants to monitor a section which might be over 6 feet deep often. Correct. This is not a place you should monitor. We only do wadable streams, so we don't monitor streams that you can't wade into, which 6 feet deep would be too deep. Yeah. Um, are we still doing the habitat assessment? Oh, great question. Yes and no. We have separated the stream habitat assessment from baseline monitoring because monitoring stream habitat is an entirely separate method that takes a couple hours to complete. It's more advanced, more complicated for volunteers to do. And so we've separated it out. And we have a whole separate training now for stream habitat assessment. So if you are interested, you can keep monitoring and doing a stream habitat assessment, and we have updated guidance on our website for that method and how often to do it, but we consider it separate from baseline monitoring now. So feel free, this is the end of our webinar. If you have questions, we'll stick on and you can unmute and ask your questions or drop them in the chat. We'll hang around for a few extra minutes, but thank you so much for joining us today and let us know, get in touch if there's anything you want to chat related to stream and river monitoring. Thanks. And